9.2 starts with simplifying radicals. We've been working with square root during 9.1, and in this lesson you will learn how to simplify radical expressions and how to recognize when a radical is written in simplest form. So here are the properties of radicals. And the one thing I want to point out is the trick to this is to try to find perfect squares. This is similar to doing factoring, where you can figure out some perfect squares, and if you do not see them right away, there are ways to simplify them. Of course, I know that you can be using your calculator, but remember that sometimes during tests or assessments, you will not be able to use a calculator. So the basic rule is that a product is, if they have an example of what is the square root of 400, you could break it into 4 times 100 because both of those have perfect roots, and so then you would have 2 times 10, and so that would be 20. All right, because the square root of 4 would be 2, and the square root of 100 would be 10. And the same thing applies to if you had a fraction or a division one, try to break it into the perfect square roots. This one happens to be there already, so this would be your answer. Both square root of 9 and square root of 25 are perfect square roots. Alrighty, so an expression with radicals is in simplest form if the following are true. And I can see that my window's not fitting, so I'm going to pause and then reset that. Hang on. So if we want to put a radical in its simplest form, we look to see if there are some perfect squares that could be factors of that. So the square root of 8, we could find the perfect square of 4. So we can change it to a product, the square root of 4 times the square root of 2. And then the square root of 4 would be that perfect square, so that can come out of the radicand sign, and it would be 2 square root of 2. It's also in its simplest form if there's no fractions. And so again, I can split the fraction one into two different factors, square root of 5 and the square root of 16. And 16 just happens to be a perfect square, so you have the square root of 4. And if no radicals appear in the denominator of the fraction, and so 1 divided by the square root of 4, 4 is our perfect square, so we can change it to 2, and that changes to the fraction 1/2. So if we want to simplify 50 to its perfect or its simplest form, we can go ahead and we can look for factors that would have perfect squares in them. And so 50 would be 25 times 2. We could use that as a product because 25 has a perfect square. And so this perfect square of 25 is 5. And there is no simplifying the square root of 2. So that is in its simplest form, 5 square root of 2. Moving along, we're going to use the quotient property. So again, we could write this as the square root of 3 divided by the square root of 4, because the square root of 4 has a perfect square. So that would be the square root of 3 over 2. So there's no radicand in the denominator. For the next one, the square root of 20 over 4, we can look for a perfect square. And again, if you're doing a factoring mentally, you could figure out that that could also be the square root of 5 times the square root of square root of 4 times square root of 5, and that's over 4. The square root of 4, that's a perfect square, so that would be 2 to the square root of 5, or 2 times the square root of 5 over 4. And then, as we always do with fractions, we can simplify that. 2 goes into 2 once, 2 goes into 4 twice, so that would be the square root of 5 over 2 would be its simplest form. Now for 32, we could think of 4 times 8. Also, your simplest one would be 16. So if I did 16 times 2, that would be my largest square root, and that will cut down on some of your steps. I'll show you the other way too. And we've dealt with 50 before. The largest perfect square of 50 is 25 times 2. So we have a perfect square here, we have a perfect square here. So this would change into 4 square root of 2 over 5 times the square root of 2. 4 over 5 cannot be reduced, but Square root of 2 over square root of 2 can be reduced. It's the same thing, so that's the same as saying 1. So that simplest form would be 4 over 5. In case you did not do the largest one, I'll show you that as well. So if I did 32 as the square root of 8 times the square root of 4, and then I went ahead and I did, we'll stay with the 50, we'll do the 20. Oh, we could do 5 times 10, I guess, to really show you an example of this. Now, none of those have perfect squares in them except for the 4. However, I can split my 8 into the square root of 4 times the square root of 2. And I can split my 10 into the square root of 2 times the square root of 5. And now I have 2 square roots times each other. So that would be 5. I cannot do anything with the square root of 2. And I have 2 square roots of 4 multiplied by each other. So I could change that to, that would be 4. And I would have my square root of 2 left over. So very much like a factor tree, if you do not see it to begin with, you just have a couple more steps. You want to go with the largest perfect square. I can also say if you do it this way, if you went to the 32 and you were doing your factor umbrella here, 1 can never be a perfect square. So we'll do 16, well not the largest one, 16 times 2, and right there we have our perfect square. Okay, 2 was our next one we would think of, and 16, and as soon as you get your perfect square, over on the right hand side, that's going to be your largest perfect square. So moving along, we have using these quadratic models in real life. So we have some chase races, and we're talking about quadratic equations, and they can be used for real life situations, such as comparing maximum speed with different water lengths. So let's go ahead and try to do this one. We have the boat racing, the maximum speed S in knots or nautical miles per hour that some kinds of boats can travel can be modeled by S squared equals 16 divided by 9 over X, where X is the length of the water line, and that's in feet. So a sailboat with a 16-foot water line is racing against a sailboat with a 32-foot water line. So there's our water lines. Okay. The smaller sailboat is traveling at a maximum speed of 5.3 knots. So our first question is find the maximum speed of the sailboat with the 32-foot water line. Find the speed to the nearest tenth. So what I'm going to do there is I would say, use my formula up here, and I would go ahead and I would say that S squared equals 16 over 9x. And then they told me that the S would be the maximum speed, and we also said that the X would be the feet. So I can go ahead and substitute my feet because I want to find out maximum speed. So it would be 16 over 9 times X for the 32-foot water line. So I would go ahead and I would replace 32 in here. Okay, in doing that, I would need to find, now to solve for S, I'm going to change colors here so you can see what I'm doing. I'm going to find the square root of both of these sides. So I can find the square root of 16 over 9. That's pretty easy. We have a perfect square there. So that would be 4 thirds. Okay, square root of 16 is 4. Square root of 9 is 32. And then let's use our product. This would be 16 times 2 as we did on the last screen. And so the square root of 16 would be 4 and the square root of 2. So now for my numerator, I have 4 times 4 square root of 2 over 3. So my final answer here would be 16 square root of 2, oh, I'm sorry, 16 times the square root of 2 over 3. Now it says that when I'm finding this, it says find it to the nearest tenth. So this would mean that you would have to put that in your calculator, and you would do 16 divided by 3 and then multiply it by the square root of 2 using the buttons on your calculator. So you're going to end up with about 7.5. And that 7.5 is going to be the knots. nautical word here. All right, so the second part of that question says, is the maximum speed of the sailboat of the 32 waterline twice that of the sailboat of the 16? And we have that the 32, again, was 7.5 knots, what we just figured out on the screen before this. And we figured they had stated that the maximum speed was 5.3 for the smaller boat there, the smaller boat. And so that is not true. And so it would be no, because 7.5 is not twice that of 5.3. And that is actually the end of the examples for 9.2. Again, look for your largest perfect square, and if not, you need to keep breaking it down, thinking about factors. You can also use the square root chart in the back of your book.